Hey everybody, welcome to the video. Let's talk about using the computer to help you solve a system of equations. And this is not specific to any particular application. You could be doing some physics or chemistry or civil, electrical, mechanical engineering, and you end up with a system of equations. Say something like this. And then now it's time to do the math. Like, how do you solve these equations to get the answer? You could solve it by hand, which you should definitely practice doing that so you know how to do it. But when you're at work, you wouldn't do that. You would just use the computer, and you wouldn't even use a calculator at work, right? You would just use the computer. So let's talk about that. If you want to see this particular problem, this happens to be a space truss. You can just pause the video if you want to take a look at this problem. It's just, given this particular space truss, you have a load here, and the question is, what are the axial forces in these three members? And you would just take the free body diagram of the whole thing, write Newton's law, Newton's second law, and sum all the torques. You can solve for the reactions at those three supports, A, B, and C. Step 2, take a free body diagram of only joint C, and that gives you these three equations, which I have a problem with this method. First of all, I don't like this round-off error here. See all these decimals? I would have left it in a better form. For example, really quick. See this unit vector CB, right? That's going from point C to point B, which is the vector. Here's C, here's B. So the vector is negative 2i plus 3k. And if you want the unit vector, divide by its own magnitude, which is square root of 2 squared plus 3 squared, which is 13. Right? So I would have left this as minus 2 over root 13i plus 3 over root 13k. Right? So, and then plug that into the computer instead of, right, already this round-off error. But for the sake of time, I'm just going to use this and just focus on how to get it into the computer. And how do we do that? Write this system of equations in matrix form. So we have three equations, three unknowns. So it's going to be a 3 by 3 matrix times a 3 vector equals another 3 vector. So here we go. First equation, this one. So minus 1 TAC minus 0.555 TBC minus 0.535 TCD equals 0. Right, so there's the first equation. Second equation is 0.802 TCD, and then let's move this to the other side of the equation, equals negative 1. So this equation, notice there's no TAC, there's no TBC, so 0 TAC plus 0 TBC plus 0.802 TCD equals negative 1. Okay, now third equation, this one, there's no TAC, so 0 TAC plus 0.832 TBC plus 0.267 TCD equals 0. Okay, now this is the one. This is what you feed to the computer. How do you do that? Well, let's talk about the algebra first. We can call this some matrix A. This is some vector x of unknowns and some vector b. So it's an equation that looks like ax equals b. Then how do you solve it for your unknown x? What is x, right? That's what we're after. These are what we're after. And you just pre-multiply both sides of the equations by the inverse of A, because then this turns into the identity matrix, and then that's all. Okay, so this is what we're trying to solve. How do you do that? Let me use either Matlab, industry standard, that's what you would use at work most realistically, but I wouldn't want you to have to pay for a license, so you can use Octave, which is free open source, and the syntax is pretty much identical to Matlab. So I encourage you to give this a try. Let me open the software and resituate my windows here. All right, I opened Octave, and let's start getting this in here. So let's type matrix A. So the syntax looks like this. A equals, and then in square brackets, first row, -1, space, minus 0.555, space, minus 0.535. And then to go to the second row, use a semicolon. So now second row, 0, space, 0.802. And then semicolon to go to the third row, 0, space, 0.832, space, 0.267. Okay, so let's say if I run this, right? So here's our matrix here, which matches what we wanted. And then next line for vector B, first row is 0, and now we already have to go semicolon to go to the second row, -1, semicolon to go to the third row, 0. So here's vector B. If I run it, matrix A, vector B. Now we want the inverse of A times B. So how do you do that? Let's ask. Okay, so the function is called inv, and it is to solve an equation that looks like A times X equals B, which is like this, inverse of A times B, but it kind of says specifically it's best to avoid calculating the inverse and to use this syntax instead. Y equals A backslash B, which is just a more algorithmically efficient method of solving a system of equations, and we'll just listen to what it tells us. Okay, so let's run it. And here we have our answer, and compare it to what we were expecting. See up here, 0.444, 0.401, minus 1.247, and of course there's round-off error as I was expecting. But now you know how to do it. I encourage you to give it a try, build up your skill in using the computer to do these things, and add it to your resume. All right, thanks for watching. I'll see you in the next video.